Today we're looking at section 9.1, solving quadratic equations by finding square roots. A couple goals. First one, evaluating and approximating square roots. The second one is to solve a quadratic equation by finding square roots, beginning on page 503. First, we have a whole page full of definitions. First one is a positive square root. This is the square root that most people think of when they see that radical symbol, when they see that house or they see that jail, whatever you want to call it. In this instance right here, we have the square root of 36. All this symbol right here means, when you see that radical symbol, all that means is what times itself. Just asking the question, what times itself gives you the number 36. Now, the positive square root, again, is the number that the majority of us think of. We don't think of the second number when we think of it. But this means what times itself gives you 36, and the answer is 6. Notice the answer is not square root of 6. It's just 6. This is the positive one. Again, this is the principal one, the one people think of. The other one is the negative square root. If you look at the negative square root of 36, again, that symbol means what times itself. The number negative 6, if you multiply negative 6 times negative 6, you also get the number positive 36. So the number negative 6 would be your negative square root. Again, it doesn't come into play a whole lot, but you have to understand that when you're looking at radicals, when you're looking at that symbol, it means both the positive and the negative number. And it comes into play more often when you're looking at graphs. You'll see when you're looking at most of the graphs we've been looking at so far have been linear equations. So when we graph them, they would look something like this. They were straight. When we look at these, we're going to look at graphs. They have parabolas when they have something squared in it. So it'll be a graph that looks something like this. It'll be more U-shaped, but we'll get to that eventually. The radicand, you pronounce that word radicand. It's a pretty easy word to pronounce. It's the number that's under the radical symbol. So just whatever is underneath that radical symbol or that square root symbol is the radicand. So the radicand in this case, what you would say is 36. Perfect squares. Perfect squares are integer numbers multiplied by themselves. What we mean by that, if you take these numbers 1, 2, 3, 4, 5, and you can keep going as much as you want, when you multiply 1 times 1, you get the number 1. That's a perfect square. When you multiply 2 times 2, you get the number 4. That's a perfect square. When you multiply 3 times 3, you get 9. 9 is a perfect square. 4 times 4, same thing. You get 16 is a perfect square. 5 times 5, you can keep going infinitely. But most often, you'll deal with the first 10 numbers. You'll deal with numbers through 100. So 1, 4, 9, 16. If you multiplied 6 times 6, you'd get the next perfect square, which would be 36. If you multiplied 7 times 7, you would get the next perfect square, which is 49. 8 times 8 would be the next perfect square, which is 64. 9 times 9 would be the next one, which is 81. And then 10 times 10, which would be the other one you'll primarily deal with, is 100. All of these listed here are what's considered perfect squares. Those are the numbers that you're going to use to break down radical symbols to make them much more usable and much more easy to deal with. An irrational number is a number that does not stop. It is a number. That's the easiest way to look at it and determine. It does not stop. Most often people talk about the number pi as the irrational number that they first think of. But if you look at the square root of 9, that means what times itself gives you 9? 3. Notice that number stops. Nothing comes after 3. That number stops. If you look at the number square root of 4, same thing. 2, that number stops. Nothing comes after it. Those are considered rational numbers. Irrational numbers are numbers like the square root of 3. That number does not stop because it's if you multiply 2 times 2, you get the number 4. If you multiply 1 times 1, you get the number 1. It's 1 point something and it keeps on going and going and going and going with numbers. That's an irrational number. So again, most people think of, when they see that term irrational, they immediately think of pi, which is an irrational number. But now we're talking about some different irrational numbers, and they'll be any, this is another easy way to think of it, any radical number that's not a perfect square. And again, these are your perfect squares, 1, 4, 9, 16, 25, and those go up infinitely. But anything that's not a perfect square is considered an irrational number. So the number square root of 3 is irrational. A radical expression is an expression involving square roots or radicals. So if you have something like the square root of 2 plus 3, that is a radical expression because it involves a square root. A quadratic equation in standard form is this. Notice it looks a lot like the standard form that we looked at a couple of months ago. Ax plus by equals c. That was the one we looked at before. Ax plus by equals c. But notice instead of it saying equals c, notice the equals c part is now plus c, and it's on the same side of the equal sign as the ax plus by. Also, this, you'd have to actually add a little bit to this equation. It's supposed to say equals 0 right here. Ax squared plus bx plus c equals 0. But notice the difference, again, another difference between the standard form we looked at in this one. Both of these, both of those letters, both of those variables right there are the same variable. One of them's squared and one of them's not, and that's the biggest difference. But it's the same variable. It's not an x and a y. And then a leading coefficient is the coefficient that's in front of the first polynomial term. So if you have something like 2x squared plus x plus 3 equals 0, the leading coefficient, just think of what the word leading means. That means it's up front. The leading coefficient, this is the first term. So the leading coefficient is the coefficient associated with that first term. So 2 would be the leading coefficient. Here's the first example, finding square roots of numbers. Notice letter A says negative square root of 49. So what you're doing, just as like the one we looked at on the bell work, where you don't include the negative when you're talking about what times itself is 49. Break that man out of jail. What times itself gives you 49? The number 7 times itself gives you 49. But then your negative has to come down in front of the 7. So it is a negative 7 for letter A. For B, it just says the square root of 49. That means what times itself is 49? What times itself is 49? The number 7. The next one says the square root of negative 9. What times itself gives you negative 9? Now, if you multiply 3 times itself, you get a positive 9. If you multiply negative 3 times itself, you get a positive 9. Nothing times itself gives you a negative 9. So there are no real square roots. It is undefined. If you ever see a negative under a radical symbol like that, it will be undefined. And then the square root of 0, what times itself is 0? 0 times itself is 0. Example number 2 says evaluate from this expression here. The square root, you read that as the square root, not as that symbol, not as that thingy, not as that box. The square root of b squared minus 4ac when you plug in the values negative 7, 8, and negative 1. First thing you want to do is you want to substitute in your values. So instead of b squared, h squared. Instead of negative 4 times ac, negative 4 times negative 7 times negative 1. Then work through your order of operations. Remember, you do your parentheses, then your exponents, then your multiplication and division, followed by your addition and subtraction. So do your exponents first. 8 squared will give you 64. They went ahead and did everything in one step, but 8 squared is 64. Negative 4 times negative 7 is a positive 28. and a positive 28 times a negative 1 gives you back to a negative 28. So you have the square root of 64 minus 28. You subtract 64 minus 28, and you have the square root of 36. Now that says what times itself is 36. 6 times itself is 36. Notice the radical symbol is on this step here, and it's gone on the last step, saying 6. And this is dealing primarily with the principal square root. We'll look at, on the next section, we'll look at them where it's dealing with both of the square roots. So the checkpoint says find all square roots right here, all square roots. So not just one, but all of them of the number, or write no square roots if there isn't one. So this is saying what times itself is 81. 9 times itself is 81. But it's not just 9 because it says all square roots. So both 9 and the number negative 9, when you multiply it by itself, gives you 81. That's not a big old huge deal. Again, it only really comes into play when you graph in the equations. You can see that it's a mirror image of on both sides, but 9 and negative 9. Number 2 says the square root of negative 64. So that would be written like this, negative 64. There is no number that when you multiply it by itself, it gives you a negative 64. That's why there's no square root for that one. A lot of y'all probably put 8 right there, or even negative 8, but it's not. Because when you multiply 8 times 8, you get positive 64. And when you multiply negative 8 times negative 8, you get positive 64. Again, a radical symbol means what times itself. You don't want to do one times the other. 121 means a square root again of 121. Both numbers 11 and negative 11. When you multiply 11 times 11, you get 121. When you multiply negative 11 times negative 11, notice you also get a positive 121. So both numbers. And then the last one looks like it's difficult, but it's really not. 0.49. Notice this number 49 is like 49, just with the decimal moved over 2 spots. What times itself is 49? We all know that that number is 7. It's going to be both a 7 and a negative 7, but you have to move that decimal over 1 time and make it 0.7. So both 0.7 and negative 0.7. For this checkpoint here, it says evaluate the square root of b squared minus 4ac, and then they give you 2 sets of values for it. So you'd plug it in would be your first step. The square root, b's value is negative 3. Now, when you plug it in, this is where it's going to make a little difference. Anytime you plug something in, you plug it in as if it were inside parentheses. So negative 3 squared minus 4 times a's value is 2 times c's value is negative 2. So the square root of all of that, negative 3 times negative 3, you do that first and you get the number 9. Negative 4 times 2 will be negative 8 times negative 2. Again, we didn't do anything to get rid of the radical symbol, so it's still the square root of all of that. Negative 8 times negative 2 is negative 16. I'm sorry, negative times a negative is a positive 16. Bring down your 9. Again, we still didn't do anything to get rid of that radical symbol. 9 plus 16 is 25. Again, it's still under the radical symbol. And that means what times itself is 25? The number 5 and also the number negative 5, if you were talking about both square root values. The principal square root, though, is 5. Do the same thing with the other one. The square root of b squared, you go back to the one that they have you. So b squared would be 9, again, plugged in parentheses squared, minus 4 times a's value is 4, times c's value is 2. 9 squared would be 81. Minus 4 times 4 is negative 16 times 2. And nothing to get rid of the symbol, so it's still there. Negative 16 times 2 is negative 32. So you have the square root of 81 minus 32. 81 minus 32 is 49. Still under the square root symbol. What times itself is 49? 7. And also the number negative 7 will work as well. Solving each equation, for example, number 3 says x squared equals 6. What times itself, or when we square what, does it give us the number 6? So x squared equals 6 has two solutions, both the square root of 6 and the negative square root of 6. Notice this expression is not the square root of negative 6, because remember, there's no solution to something like that. This is an irrational number. There is no perfect square that's a part or that's a factor of 6. The square x squared equals 144. There are two numbers that when you square them, they give you 144, both 12 and negative 12. Notice this is just backwards of the stuff we looked at a second ago. We were looking at square roots. Now we're looking at squaring things. And then x squared equals negative 7. There is no number that when you multiply it by itself, it gives you a negative number. Any negative number. It doesn't matter what number that is. Any negative number, there's no solution. 5x squared minus 20 equals 0. The first thing you need to do, remember your order of operations tells you to do parentheses, then exponents, then multiplication and addition and subtraction. But when you're undoing something, remember you always go backwards. So you do addition and subtraction first. So get rid of minus 20 by adding it to both sides. So 5x squared equals 20. That's the first thing. Then get rid of your multiplication and division. Get rid of 5 times something by dividing both sides by 5. 20 divided by 5 is 4. So you have x squared equals 4. X squared equals 4. In order to undo something being squared, take the square root of it. Remember, it's just like backwards of what we were just doing. If you take the square root of the left side, do the same on the right. It'll cancel this out just like the rest of our operations cancel. Now it says x equals the square root of 4. What times itself is 4? So notice it's both a positive and a negative 4, because both positive 4 and negative 4 will give you that answer. And then it's a perfect square. So notice it comes from outside of the radical symbol, or the man escapes from jail. And x is both a positive and a negative 2. And then the last checkpoint real quick, x squared equals 11. X squared equals 11. Undo this squared by taking the square root of it. So what you have, when you do that, these cancel and gives you just x equals the square root of 11. There's no perfect square that's a factor of that. So x equals the square root of 11 and the negative square root of 11, both of those answers. 3x squared minus 75 equals 0. Undo minus 75 by adding it to both sides. Again, just balance the equation out. 3x squared equals positive 75. Get rid of 3 times something by dividing by 3. Balance it on that side. X squared equals 25. Undo squaring something by taking the square root of it. If you take the square root of the left, take the square root of the right. This one will cancel out and leaves you with just x equals the square root of 25. That says what times itself is 25, both 5 and negative 5. And then the last one, get rid of minus 22 by adding it. So you have 2x squared equals 72. Get rid of 2 times something by dividing by 2. X squared equals 36. And then get rid of squaring something by taking the square root of both sides. This one will cancel. Leaves you with x equals the square root of 36, or x equals what times itself is 36, both 6 and negative 6.